So now we're going to be starting Unit 4, which is a unit on parallel and perpendicular lines. And we're going to need to learn some terminology before we can even start talking about some of the things that we need to learn. So take a look at these three lines here on this diagram, and notice that the way these angles have been labeled, we are paying special attention to how this line, which we call the transversal, so this is called the transversal, intersects these other two lines, and the angles that are created as this transversal intersects another two lines in the same plane. So a transversal basically is a line that intersects two other lines in the same plane in exactly two distinct points. So there's one point here, this one point here. Now, in many of the cases we're going to be considering, these two lines will turn out to be parallel. And many characteristics and properties of parallel lines are revealed when they are intersected by a transversal. But as you can tell from this diagram, these particular two lines are not drawn to be parallel. Nevertheless, the terminology is very much the same. And now we're going to talk about the terminology of angles, in particular the angles around these 2 points where the transversal cuts the other two lines. Corresponding angles. Corresponding angles are angles at the same position at each intersection of the transversal. So corresponding angles are angles at the same position as at each intersection point. And these are our two intersection points, there and there. Those are our two intersection points. So by position, and by the same position, we mean that if you're at the point, the angle that is in the upper right-hand corner, for example, which would be 2 here, is a corresponding angle. Then when we go down to this point, and we look at the point that's in the upper right position here, we see 6. So 2 and 6 are corresponding angles. 3 and 7, which are in the lower right, in reference to each of these points, are corresponding angles as well. 1 and 5, which is sort of on the upper left-hand side of the points, are corresponding, as are 4 and 8. So one example of corresponding angles would be, for example, angle 4 and angle 8. Those are corresponding angles. And as we mentioned, there's 4 pairs of corresponding angles that we've already seen. The next definition is same-side angles. So same-side angles, the side that we're referring to when we refer to same-side angles is the half plane formed by the transversal. So this is our transversal. Okay, this line that's cutting down this way is a transversal. And everything on the right of the transversal is on the same side. And everything that's on the left of the transversal is also on the same side. But things which are on the right are not on the same side as things which are on the left. So that, for example, angles 2 and 3 are same-side angles. Angle 3 and 6 are same-side angles. And angles 6 and 7 are same-side angles, as are 2 and 7, because they're all on the right side of the transversal. Angles 1 and 4 are same side. Angles 5 and 8 are one side. Angles 1 and 5, 4 and 5, 8 and 1, they're all same side also because they're all on the left side of the transversal. However, angle 2 and angle 5 would not be same side angles because angle 2 is on the right side of the transversal and angle 5 is on the left side of the transversal. Okay, so same side angles are angles that lie in the same half plane formed by the transversal. And as examples of some same side angles, we already said like 2 and 6, 2 and 7, 3 and 6, 3 and 7. So let's put 2 and 7 down. Angle 2 and angle 7 would be good examples of same-side angles. And there's lots of them, as we've seen. So alternate angles, which is the next definition down here, are actually the opposite of same-side angles. Okay, so alternate angles are angles that lie in opposite half planes formed by a transversal or formed by the transversal. Okay, so that the angle we mentioned that wasn't a same-side angle pair, angle 2 and angle 5, for example, they are alternate angles because they are lying on opposite sides of the transversal. So 2 and 1, 2 and 8, 2 and 5. There are certain types of alternate angles that are more important than others, but basically anything that's not a same-side angle would be an alternate angle. Okay, so far we've dealt with right side and left side that have to do with the positions that are made by the transversal. We also have another set of angles, or sets of angles, that are called interior angles and exterior angles. And they don't have to do so much with their position related to the transversal as they have to do with their position related to the parallel lines. Interior angles are angles that lie between the two lines. Well, I said parallel lines. Usually we'll be talking about lines we at least suspect are parallel, but in this case they're not. But still, angles that fall between the two lines which are intersected by a transversal are interior angles. So these are angles that lie between the lines cut by the transversal. So that, for example, so what are the such angles? Well, angle 3, angle 4, angle 5, and angle 6 are all interior angles because they're all lying between these two lines. Okay. Now, what would exterior angles would be the other sets of angles that don't lie between the lines. So basically, exterior angles are angles that don't lie between the lines cut by the transversal. Okay, so what would be some exterior angles? Well, 1 and 2 don't lie between the parallel lines, right? They're outside that space between them. And 8 and 7, or 7 and 8, also don't lie between these two lines. Let's call them A and B. Okay, so examples of exterior angles would be angle 1 and angle 8. And also angle 2 and angle 7. They're all exterior angles. What would be, let's just back up, I didn't really give you examples of interior angles. Well, we already said 3, 4, 5, and 6 would be the interior angles. So angle 3, angle 4, angle 5, and angle 6 would all be interior angles. And alternate angles are pairs of angles that are in opposite sides of the transversal. So, for example, 8 and 2 would be alternate angles, angle 8 and angle 2. Notice that corresponding angles and alternate angles are pairs of angles. Okay, so we always have to talk about a corresponding pair or an alternate pair. Same side angles could be several angles, could be same side, as well as interior and exterior angles. You could just list the angles that are either between the parallel lines or outside of the parallel lines.